Hi guys, this is Miss Eisencraft and I'm here to go over the little Delta Math assignment, so if you need any help. So it should say week 8, day 2 vectors. The first one, adding vectors graphically. So you could do it numerically, but the focus is on the graph. So vector u and v are already here. You need to add them. Well, adding is usually like commutative, doesn't matter which one you start with. So it wants you to either drag this vector to the end of this one or this one to the end of this one. Let's see. Boop. Where does it end? It looks like it ends at -1, -5. Now, let me just show you guys something. If I would have, it's not letting me grab that one. That's funny. I think some of times it lets you grab the other one. It wouldn't matter which one we grabbed first, as long as you're putting the beginning to the end. It ends at -1, -5. Let's see if we are right. Boom. And you could kind of see that if you add 1 plus -2, right, the horizontal components, you would get -1. And if you add the vertical components, -8 and 3, you'd have gotten -5. But the whole idea is to visually see that by combining them and illustrating that. Okay, so let's go back. Let's try the next one. Multiply vector by scalar. So you're going to stretch it. So here's a vector v, find 2v. Well, 2v would mean twice as long in the same direction. You just grab it and draw it. So it was 4, -1, it'd be 8, -2. And numerically, yes, you could have just doubled and doubled, but it wants you to show you're going twice as far in that same direction. Sometimes there's some negatives involved, which means just take the arrow and go backwards. You have to like kind of draw it onto itself to go backwards. Okay, let's try the combining scalar multiples of vectors graphically. So we're going to take 2 of the u's and subtract 2 of the vector v's and subtract 3 of the u's. So let's start with 2v. So I'm going to take v. Okay. Now, if I'm going to subtract u, I need to go the opposite direction. And so that is why they have -u. Okay, because when I subtract u, it's like I'm adding a -u. So now I need to subtract 3 of these -u's. I'm sorry, I need to combine 3 of the -u's or subtract 3u. Boop. A little infuriating moving these correctly, yeah? Stop talking to me, Mr. Thing. And you just grab it. You can kind of basically see what's happening. So you had 2 of vector v, and then you subtracted or added 3 -u's, and we are at, you subtracted 3u or added 3 -u's. I keep saying that wrong. I'm so sorry. -3, -8. Let's see if I did it right. Sure. Cross my fingers. What? I got it right. Yeah. The expression 2v minus 3u is really the same, 3 -u's and 2 v's adding from tail to tip. And look, they did the -u first. They did 3 of the -u's and then they added it. And because it's addition, you could do it in any order, right? Because it's represented as addition, you're good to go. Look at that. They show both different ways. It's so cool. Okay. Then these two guys, adding vectors numerically. Let's see what's happening. Oh, they don't give us anything. What? Okay, so they take away the graphics. So u and v, you need to add the horizontal component. And then if you are like me and it confuses your eyes, you like to stack them so that you make sure your horizontals are on top of each other and your verticals. Or I always have to draw these arrows, or I tend to add the wrong numbers. Not sure if it's diagnosed dyslexia, but something close. Okay, let's go. So that looks like it's -5 and +3. If I did it right. Yeah, you're combining the horizontal component with the vertical component. Boom, boom, boom. Sometimes it's easier to stack them vertically if you have a hard time seeing if they jump around on you. And that's a real thing. The numbers can jump around on you. All right. Last one. Okay, let the vector v have an initial point at 0, 2 and a terminal point at 1, 6. Okay, so basically what it's saying here, let me go ahead and sketch this. I'm going to sketch this, right? Okay, 0, 2, and then it has the point 1, 6. Okay, so we're asking like from 0, 2 to 1, 6, like how far did it go from this point to this part, and we're not from this point to this point, and we're not starting at the origin. So since we're starting at 0, 2, from 0 left to right, we had to go 1 to the right. So this had to go 1 to the right, and then the vertical component was 4. So you're basically subtracting. You have to do this with like slope, right? Rise over run a lot. So basically, for the horizontal and the vertical components, you're subtracting these. Or you can draw it out and say, how far did I have to go horizontally? 1. And how far vertically? 4, right? So subtraction is one way to do it, right? And you do that. That reminds me in middle school of slope. You're subtracting your x's for the horizontal. You're subtracting your y's for the vertical. Let's see if we got it. Amazing. Look at how smart we all are. All right. Hopefully that helps. Good luck. So the vector stuff isn't that complicated. It's just sort of sorting out what it all means and being able to graphically represent stuff you could do numerically, because it's pretty easy to kind of mix stuff up numerically, even though it's so easy. All right. Good luck, everybody, if I know how to turn this recording off. And boom. Nope, just kidding.